Welcome to the Dr. Gundry podcast. All right, what do you have in common with a locust? Well, my guest today says that you have a lot more in common with the locust, a grasshopper, than you think. In fact, this similarity isn't limited to locusts. It's something we share with every single animal in the entire animal kingdom. And it could change the way you think about food and diet forever. I'm joined today by Dr. David Raubenheimer. David is the Leonard P. Ullmann Chair in Nutritional Ecology at the University of Sydney in Australia and co-author of the incredible book called Eat Like the Animals, What Nature Teaches Us About the Science of Healthy Eating. And it's also just out in the paperback edition. And believe me, I absolutely love this book, which is why in today's episode we're going to dive deep into its contents. You're going to learn the truth about your food cravings, how much protein you should really be eating, what so many diets get so completely wrong, and much more. Boy, that's a tall order to fill on our podcast. So I can't wait to get started. David, welcome to the podcast.
Thank you very much, Stephen. It's a pleasure, and thanks for inviting us to be on your podcast.
So, your book is fascinating to me. How in the heck did your research get started? Why were you looking at locusts? And what the heck does that have to do with humans?
We actually set out asking a very simple and very important question, and that is, how do animals in their natural environments balance their diets? Now, we know that dietary balance is critically important. We've known that for many decades, so over a century for humans, for laboratory animals, we know that. We know that for the pets around us, agricultural animals. The real question then is, how do animals in the wild balance their diets? We know that we rely on science to balance human diets and pet diets and agricultural diets, but how do animals without science do it in their natural environments? That's the question we set out to answer.
So what you're saying is they're not going and looking at labels on packages saying, my macros have to be 35% carbohydrates and 15% protein. They're not reading a label.
They're absolutely not reading a label at all, and they have no access to science. And it's a complex task in a natural environment. Some of the primates that we've studied eat up to 450 foods. How do they know how to eat the right combinations in the right proportions to provide the nutrients that they need? That was the question we set out to answer.
So, and your research has gone, in amazing depth, kind of throughout the animal kingdom. And what if you looked at cockroaches, you looked at locusts, you looked at mice, and even humans, you looked at apes. What have you learned in a nutshell? And I want you to go as deep as you want to here, because I think it's fascinating, about diet and protein consumption in particular.
So I'll start by explaining why we started to work with locusts. What we were trying to establish was a general understanding of how animals balance their diets in a natural situation. And for that, we were looking for a convenient and expedient species to work with, one that we could raise in large numbers in the laboratory, that has a short life cycle, so we could feed them different diets, and we could measure what would be long-term outcomes in humans or many animals, like growth rates and reproduction and lifespans. We could do these things with a lot of manipulations. We could provide foods that we had defined exactly their composition, and we could really unravel at a high degree of detail what is driving their dietary choices. So we started out with locusts in those sorts of laboratory experiments. Very convenient system. And what we actually found with these locusts is that they have not a single appetite, but they have several appetites, each for a different nutrient. So when they're hungry, when they have not eaten enough protein, an appetite for protein kicks in, and they specifically seek out protein. When they've had enough protein, but they haven't had enough carbohydrate, they become not generally hungry, they become specifically hungry for carbohydrate. And in this way, these separate appetites, which is the body's way of telling behavior what it needs at any one time in terms of nutrition, directs the animal's feeding choices to eat the appropriate foods at the right time according to what it is that the body needs. So effectively, you can think about it as separate appetites for different nutrients working together, collaborating in order to help the animal to select the diets in the right proportions that provides the nutrients that it requires. In other words, a balanced diet. So that's what we discovered firstly in locusts.
And so how, at the basic level, how does a locust decide he or she is deficient in protein or carbohydrate? What's the mechanism?
The mechanism in a locust is, or in insects more generally, is fairly simple and very different to the mechanism in mammals like ourselves. When a locust has eaten enough protein, then the circulating amino acids in the blood, in the open bloodstream, dampen out the sensitivity of the taste receptors. So they stop tasting protein. So they no longer respond to high protein food as if it's delicious. When it's eaten enough carbohydrate, but they continue to respond to high carbohydrate food as if it's delicious. So when they've got enough protein, that's what causes them to eat more carbohydrate. They stop tasting protein, but continue to taste carbohydrate. And then vice versa, when they've got enough carbohydrate, but they need protein, they no longer taste and respond to carbohydrate, but they do taste and respond to protein. Now, in terms of the broader picture, what we then did, after discovering these separate appetites and the ways that they work together in locusts, is we asked the question, we set out to understand how general this is. How general is it that animals have these separate appetites that work together in order to balance the diet? And what we found over many decades of work is that it's extremely general. In fact, it's more than extremely general. It's probably universal. We've demonstrated this now in organisms from slime molds, which are big, or they're single cellular animals that don't even have a brain, but they have similar kinds of mechanisms for sensing nutrients and responding to what they need at any given time, exact equivalent of a nutrient-specific appetite, through to many species of insects, spiders. We've worked on cats, dogs. In the laboratory, we've worked on many species in the wild of primates. We've also worked on humans. And what's common across the diversity is they have these same types of nutrient-specific appetites that enable them to balance their diets.
I thought one of the most remarkable things that I took away from the book is the interest or the level of protein that is actually sought by kind of across the spectrum. Can you go deeper into that and why that nutrient seemed to be so universal driver of appetite?
Yeah, so that's a great question, Stephen. So I'll just clarify that the actual levels sought by animals is different. So predators seek a higher level of protein than what omnivores do generally, than what herbivores do generally. But what many animals, and not all, but many animals that we've studied do is, if you think about these appetites interacting and balancing their diet. Now, in the natural situation, there are often circumstances in which the range and variety of foods that are needed to balance the diet is not available. So the animal, for example, primates that we study in the wild, they use fruits to get fats and carbs, and they use leaves to get protein. Now, for long periods, there might not be available fruit. So then they're stuck on an imbalanced diet. And there's a bit of a challenge that they have to solve. These appetites can't work together to balance the diet because ecology doesn't permit that in those circumstances. So effectively, they have to decide how to trade off those nutrients. Are they going to get the right amount of protein, in which case they'd eat too little fats and carbohydrates? Are they going to get the right amount of fats and carbohydrates? But to do so, because the diet is imbalanced, they would have to eat too much protein, or what are they going to do? Which of those appetites prevails in situations when they come into competition in that way? And what we found for many species is that the protein appetite is the one that is stronger than any of them. So it's the protein appetite that prevails. And what that means is that regardless of the ratio of fats, carbohydrates to protein in the diet, on a daily basis, they always eat the right amount of protein, meaning that if the diet proportions are too high in protein relative to fats and carbohydrates, they'll eat too little fats and carbohydrates. If the proportion of the foods available is too high in fats and carbohydrates, they will have to eat too much fats and carbohydrates to get the right amount of protein. So the question then is why? What is so important about protein that causes them always to defend that, regardless of whether they causes them to overeat or undereat other nutrients? And the answer to that is probably that we need to think about it in two contexts. Why don't they settle for too little protein? And then why don't they overeat protein to get enough fats and carbohydrates? Starting out with why not too little protein? I think the main reason for that is that the body doesn't have an effective means of storing protein. And that means that it needs protein on a daily basis. It needs it for growth, it needs it for all enzyme activities, for reproduction, repair, immune responses. Protein is really needed on a daily basis. But because we can't store it, it means that we have to ensure that we get enough of it in our diets on a daily basis. And that's why we ensure, and many other species do, that every day they eat the right amount of protein. Why don't they eat too much protein? The answer to that is probably that if they eat too much protein, they have to detoxify. That what they have to do is they have to get rid of the amino acids, which means removing nitrogen from the amino acid, which is a toxic process. That's the first thing. So there are costs to getting rid of too much protein. And the other thing, which we will speak about in more detail later, no doubt, is that we know that eating too much protein is associated with an acceleration of the life cycle. And it shortens lifespans. It's associated with early onset of age-related diseases. So that's why animals have to ensure on a daily basis they get the right amount of protein, neither too little nor too much.
And I think it was fascinating, your research, particularly like in cockroaches or locusts, you were able to manipulate in minute detail exactly what levels of protein or carbohydrates in the diet and see what happens. So this wasn't just conjecture on your part.
Absolutely not. One of the important things about using insects, as we discussed earlier, is that you have that capability. And locusts, they like to eat, as we know. Cockroaches like to eat. So we could manufacture artificial foods whose composition not only did we know precisely, but we could manipulate absolutely precisely. And when we saw a response in terms of the animal's feeding behavior or its growth or its body fat, we knew exactly what was driving that response because we had controlled the composition of those diets. So it wasn't conjecture at all. And what that did for us is it showed us that these mechanisms are real. That showed us that in the laboratory work. So it enabled the next step, which is we could then move out into the wild and ask, well, how relevant are they in the natural lives of animals? Of course, the laboratory is not the natural lives of animals. And knowing with the confidence from laboratory work that these mechanisms do exist enabled us to interpret how they operate for animals in their natural everyday environments. And that's been, we've had the same relationship in human studies. We've done the experiments in the lab for humans, and that really helps us now to interpret the diet survey and other epidemiological data, which indicate what we do in our everyday lives in a real context rather than outside in the laboratory.
So, what is that? So, and you go into this a great deal. What does protein, or maybe the lack of protein, do in a human diet to make us overeat? Can you talk about that a little bit?
Absolutely. So, like many of the species, other species that we've studied, including many non-human primates, humans regulate their intake so that they prioritize protein. That means on a daily basis, they always get enough protein. That's what we do. We aim, our appetite systems aim at. What that means is that anything that dilutes protein in our diet is going to be overeaten in order to achieve that daily protein target. And the relevance of that is that if you look at the recent history of human food systems, protein in the diet has become, especially over recent decades, it's become diluted by the addition of simple carbohydrates and fats in the form of processed foods. And these strong protein appetites that we've evolved in natural environments are therefore causing us to overeat fats and carbohydrates in order to meet that protein target. This is what we call the protein leverage hypothesis, that it's that dilution of protein in a human diet interacting with our strong protein appetites that is driving the overconsumption of fats, carbohydrates, and energy, resulting in an obesity epidemic. Now think about that. What that's saying is it's saying that the reason we get fat is not because we have strong appetites for fats and carbohydrates, but because we have a stronger appetite for protein. That's a very different perspective.
And what you're saying is because so many of our processed foods and even grain-based foods are actually very low on protein content, we'll keep eating until we reach that set point of protein goal to get to that point.
Exactly. Another way of thinking about it, we will stay hungry until we've reached that protein goal. And that will cause us to overeat fats and carbohydrates in the process. Once we've eaten enough protein, we tend to be satisfied, satiated.
So does that mean that if I eat, and we'll go down this rabbit hole, if I eat a carnivore diet, which is now popular in the United States, and basically all I'm eating is protein, maybe there's some fat base in there as well, are you saying that, number one, I'll get to a point and I just will lose my appetite for any more protein? Or what's going on?
That's the flip side of the processed food scenario, where the processed food, we're diluting protein, so we're overeating fats and carbohydrates. If you're on a carnivore diet, what we're doing is we're concentrating protein, so by the time we hit that protein target, we have undereaten fats and especially carbohydrates, or both. We've undereaten non-protein energy, fats and carbohydrates. And of course, that's why high protein weight loss diets work. In the short term at least, because we become satiated at a lower intake of fats and carbohydrates and energy than we would on a low protein diet.
And to carry that one step farther, what you're saying is eventually, and certainly from my clinical experience, most of these fail because we haven't gotten enough of the carbohydrate and fat in our diet that receptor is looking for. Is that, to paraphrase you correctly?
Yes, that does. So our work has shown it's not only the protein appetite, we've got appetites for fats and carbohydrates as well. The protein appetite is the strongest, which causes this protein leverage effect. But those other appetites are still active. And if we, over a long period, deprive them of, say, carbohydrates, we build up cravings for carbohydrates. So ultimately, it takes willpower to stay on a diet that is imbalanced. It's not calibrated to what our It doesn't have the balance that our appetite systems are calibrated to, are set to, for a human balanced diet. And those very high protein diets most certainly are imbalanced in relation to human appetite systems. We've shown this in experiments in the laboratory. And you can see it if you look at global population data. No populations, with a few very rare exceptions, like the traditional Alaskan Inuit populations, eat a diet of that level of protein, because the human appetite systems just aren't calibrated for that kind of a diet. We build up cravings, and ultimately only willpower can stop us from succumbing to those cravings. And we don't want willpower to be involved in eating. We want to follow our natural pleasure pathways, which actually is what our appetites dictate.
Well, I'm glad you said that, because you're right. There really is not a successful long-term society, particularly a long-lived society, that's based on a high-protein diet. They simply don't exist. And you would think, if that was such a great diet that we were designed for, that there should be multiple examples
Absolutely.
that you could find, that I could find, and they don't exist.
And those that do exist, so the Arctic Inuit, for example, interestingly, they have been found to have genes specific in high frequencies in their populations that prevent them from going into a ketotic state. So it's not as if they eat a high protein diet and therefore it's a good diet for human populations, so too should we, because in the context, the ecological context where they evolved eating such a high protein diet, it appears that specific genes have been selected to protect them, presumably from the negative effects of some of the negative effects of that high protein diet. And they're certainly not renowned for their longevity in the way, for example, that the Japanese Okinawan populations are, or the Blue Zone Mediterranean populations, or the Tsimane of Bolivia, or the Kitavan Islanders. All of these populations that are renowned for good metabolic health into late life, they eat a low protein diet, not a high protein diet.
Yeah, I agree. And in my book, The Longevity Paradox, I really point out that I think the unifying feature of all these blue zones, which have wildly different diets, the unifying feature is they all eat a low protein diet compared to normal. So why aren't these people, obviously everybody's now asking, okay, so they're eating a low protein diet and they're all living a very, very long time, and you say that that's good, Dr. Gundry says that's good, so why don't these people all get fat because they're eating a low protein diet? What say you, Professor? Come on.
That's a great question. And the reason is that it depends what dilutes the protein in their diet. And specifically, we have a tendency to speak of a carbohydrate as a carbohydrate. And in some contexts that works, but in many contexts it doesn't work, because there is a variety of types of carbohydrates. What the healthy populations are diluting the protein with is healthy categories of carbohydrates, by which I mean specifically what's known as resistant starch. What we are diluting our protein with in industrially processed foods is not resistant starch, but it's highly refined carbohydrates in the form of sugars and refined starches, which are physiologically very different than resistant starch. So that is the first reason. The second reason is, and in fact, we've just recently shown in mice that you get exactly the same response in laboratory experiments on mice. If you dilute protein with refined carbohydrates, you get the worst outcomes. If you dilute protein with complex carbohydrates like resistant starch, you get the best metabolic outcomes. So what we're proposing happens in humans, we've now seen happening in other species as well in the laboratory. That's the first thing. The second thing is that processed foods are not only high, industrially processed foods are not only high in bad refined carbohydrates, but they're also low in another very important dietary component, which is fiber. Now, the diets of all of these healthy populations have low protein relative to healthy carbohydrates and high fiber. And fiber, like protein, is a very strong satiating component of our diet. So these populations don't become hungry on a low protein diet, causing them to overeat because the fiber satiates them and fills them up. It's playing the role that protein would play in a more industrialized society. And that is that the fiber plus low protein satiates them. They don't overeat. For us on low fiber industrial diets, it's all up to protein, and that's what causes us to overeat these refined carbohydrates and also fats, driving obesity. The fundamental differences in the types of macronutrients and fiber is what is driving this difference between the populations.
Yeah, in my new book, The Energy Paradox, I make, again, a plea that one of the most important things we have to get back into our diets are the resistant starches and the prebiotic fiber. And in fact, you're probably aware there's now a gut-centric theory of hunger, that our microbiome and its desires is a big piece, at least in my opinion, of what drives just hunger in general. And there's some nice work out of China looking at volunteers who fasted either 7 or 14 days doing a complete water fast, but were given about 100 calories of prebiotic fiber a day, which obviously can't be digested by us, but the gut microbiome could, and they had absolutely no hunger despite a 14-day water fast.
That's very interesting, and it doesn't surprise me at all, because the gut microbiome, it's like an organ that has evolved with humans and other species, but it's different to an organ in the sense that it's very rapidly adaptable. It's because it's a community of things that grow, each component grows. So I would suspect that it plays very important roles in modulating that relationship between our physiologies and our environments, our nutritional, our dietary environments, and lots of evidence is now suggesting that that's the case. So I think it's true to say that one way to look after your health is to look after your gut microbiome. And one way to look after your gut microbiome is to feed it the right balance of nutrients that it requires. And this is where both fiber and also resistant starch comes in. Because if we eat refined carbohydrates, we tend to absorb them in the small intestine before they reach the large intestine where this microbiome lives. Resistant starch is called resistant starch because it's resistant to that absorption, and so it travels right through the gut to feed the gut microbiome and produce the benefits of a healthy microbiome.
Oh, you must have read all my books. Bless you.
I will now.
All right. Yeah, you'll see we're coming at this the right direction, the same direction. All right. So what do most people get right about fiber, and where do they go wrong about fiber?
I think most people, not all people, but most carnivore diets, extreme diets tend to be an exception. But most people, what they get right is they realize the importance of dietary fiber in the diet. And partly, I think, through personal experience, through gut function, for example. A low fiber diet is very apparent to a person that something's not right. What they get wrong is overestimating the amount of fiber that they eat relative to the amount that they should be eating. I think that's one of the things that people get wrong. So in the United States population, for example, only, I think the estimate is about 5% of the population meets the official guidelines in terms of daily fiber consumption. That is not a lot. That is not good. In Australia, it's slightly different. Australia is one of the countries where by Western standards has a relatively high fiber intake, and yet there are still some fiber deficiency diseases at high levels in the population, like bowel cancers. So fiber has a protective function against bowel cancers. And that brings me to the second thing that people get wrong. And that is that fiber is not a single thing, just as carbohydrates are not a single thing. They're different kinds of fiber. And the data are increasingly suggesting, the science is suggesting that we need a diversity of fibers in our diet to fulfill our own physiological and our gut microbiome requirements. And the problem with Australia, even though it has a relatively, by Western standards, high fiber diet, which is still below the recommendation, but it's not a very diverse source of fibers, and that's one possibility. So the problem, I think, is people don't realize just how much fiber they need, what a diversity they need, and they also think that it's horrible stuff to eat. It's difficult to prepare. It's not tasty. All the wrong things. Actually, a high fiber diet is a really and they think it doesn't fill you up. And that's the exact opposite of what's true by various well-known mechanisms. So that's what people don't understand about fiber, unfortunately.
So what do you, I know you write about this, what do you think about the ketogenic diet, the keto diet, the ultra high fat, low carb, fairly low protein diet? Where does this fit in?
Well, it fits in a number of contexts. It's compatible. Not the diet's not compatible, but it fits into our understanding of macronutrition in the sense that it's not just in with a few exceptions, it's not sustainable into the long term. In the long term, I think it's achieved support among the general public because there's some context, extreme medical context, in which it provides benefits, but these are short-term benefits. In other words, for some purposes, it's a good therapeutic diet. So, for example, managing in the short term acute radical diabetes, there are benefits to it. The difference between a long-term normal diet and a short-term therapeutic diet is a very important difference. One is to manage an emergency situation, and the other is to keep you out of emergency situations in the longer term. And to confuse those two things is a big mistake. It's not sustainable because we have carbohydrate appetites that build up cravings for carbohydrates, so people tend to go back or overshoot in terms of carbohydrate intake. And the other thing about not only the keto diet, but very high protein diets is that because of the low either carbohydrate and or fat content, we do overeat protein to a relatively small extent on those extreme diets, but we still overeat protein. And we now know that there are costs associated with overeating protein. It accelerates the life cycle, and it's associated with early onset of later and midlife poor metabolic health and shortening of lifespans. So those are the things that I think are problematic. One is it's not sustainable, which might be a blessing in disguise. The other is that it's associated with overeating protein. And the other, of course, is undereating beneficial carbohydrates is a really important part of the problem with them, I believe.
Yeah, this overeating of protein, and you mentioned early on that protein overconsumption ages us. And certainly that's been my research actually since college. And I'm a low protein advocate and have been for most of my career. That runs up against a lot of people who say, don't be ridiculous, protein doesn't age you. But in fact, your research and every research that I've ever come upon says the protein ages us. Can you tell us what are the mechanisms? Why does that happen?
So I'll step back a little bit and just think about the evolution of these things. It's really important for an animal to coordinate its life cycle with nutrient and resource availability in the environment. The most important thing an animal ever does is to reproduce from an evolutionary point of view. And if you go off half-cocked in terms of reproduction, you reproduce too early when the resources are not available, you're going to miss a valuable opportunity for evolutionary success. So for this reason, animals universally, this is a fundamental requirement, have evolved pathways that are sensitive to nutrition in the environment. And there are two categories of pathways whose balance is determining the effect of protein on lifespan. The one pathway is an accelerator or go pathway. And when that senses high protein, high resources in the environment, what it does is it kicks in the metabolic events that are associated with muscle growth, with reproduction. It's all go, get the reproduction over, and unfortunately what that correlates with is a shortening of lifespan for reasons I could go into. The other pathway, when it senses low protein, what it does is the opposite, is it slows down the go response. It stops growth, reproduction, and it focuses on maintenance and repair, on ensuring the investments are such that the body has the best opportunity to get through that period of low resources and reproduce when it's over. And this is what protein does, is it triggers the go pathway and inhibits the slow pathway, whereas low protein triggers the slow pathway and inhibits the go pathway. And it's the right balance of those things that we should be aiming at, not too slow, but not too go. And excess protein, unfortunately, falls into the latter category.
And so do most animal systems, particularly when an animal is young, when reproduction is obviously high on the list, do animals tend to overeat protein in their reproductive years? And then, well, go ahead.
So it changes. It depends what you mean by overeat protein.
Well, at least get to where you need to be.
Right. So many animals, it's very interesting. Humans and primates are really interesting in that regard because human and primate milk, which of course is the first feeding stage within the life cycle and critical component of reproduction, human and primate milk is surprisingly low in protein, which gives rise to the question, why should this be if growth is such an important thing and protein is associated with the go pathway? But it fits exactly with what I was speaking about previously, and that is for primates, there's a benefit to slow development period because we've got these growing brains whose function it is to come to know the environment, to learn the skills that are required in order to be successful in that environment. And for this reason, I believe primate milks are particularly low in protein because it slows and prolongs that process. Anthropologists call it the embodied capital idea, where part of the biological value of the animal comes not through biological development, but through its experiences with the environment. And the bigger the brain, the longer that period should be. And this fits very nicely with what I was saying earlier on, because of the primate milks, of course, all primates have relatively big brains, and humans have the largest of all primates, and human milk is the lowest in protein. So it fits very nicely with that idea. We know from animals in the laboratory, later on in life, we know that as their requirements change, for example, with reproduction, their diet selection changes to track those requirements. So we know that insects we've studied in the laboratory and that reproduce, they select a higher protein diet. The primates that we've studied in the wild also change their diet selection in association with gestation, with pregnancy, and particularly with lactation. Although with lactation, it's not towards a higher protein diet, often it's towards a higher energy diet for the reason that I've just described, that primates have a low protein milk. So yes, animals do change their diets in association with specific requirements as they go through the life cycle. But I wouldn't call that overeating protein. I would call that eating protein to a different target that is most compatible with their requirements at that time.
Gotcha. Good explanation. Okay, I want to switch gears. You spend some time in the book talking about ultra-processed foods. Now, my listeners probably know these foods are bad for them, but in the book you go into really why they're so bad. So can you lay it on us? Why are ultra-processed foods so unhealthy?
The reason that they're so unhealthy is that the causality has kind of been inverted in a weird way. So our bodies have evolved to respond to combinations of things that are beneficial to our physiology and our well-being. What's happened with ultra-processed foods is that those responses have been hijacked or hacked by science, food processing science, to get us to respond in an abnormally enthusiastic way when the health benefits don't come with those responses. So that's the general inversion. So what's being optimized with ultra-processed foods, unlike natural foods, is not health, but it's commercial benefits to small sectors of private sectors of the society, to companies who produce them. And they're very good at keying into human biology to cause us to select those foods, but for their benefit, not for our benefit, in terms of health versus profit. How do they do that? There are a number of ways. One is, of course, additives that make these processed foods taste unnaturally good, but have nothing whatsoever to do with health. So, for example, there are long lists of these things that are used, but there are few that I like to use as examples. Something called piperonal that provides an artificial vanilla flavor to some processed foods, ice creams, for example. Now, this is an industrial chemical. It's moonlighting in the ice cream industry, but it's actually also used, or it was historically used, to kill head lice in hospitals. So you get the scale, or other compounds like benzyl acetate, which is a mimic of a strawberry flavor. That's also used in plastic manufacture as a solvent in plastic. Or isoamyl acetate is a mimic of banana flavor. Benzyl acetate is strawberry flavor. So these things are mimicking healthy foods and causing us to respond naturally, but it's not the nutrition we're getting that we would be getting in a different context. So artificial additives are one of the things, and some have really ended in tears. So the one hydrogenated fats, for example, these were used not so much to flavor foods, but they were used to cut the cost of producing the foods by using cheaper vegetable oils, transforming them to a form where they act like butter, more expensive butter, and they're solid at room temperature. So that's the industrial process of hydrogenation, and that turned out, still to this day, a large number of people, it's not banned in all countries. In some countries it is, but a large number of people annually die of cardiac disease, heart disease associated with these things. So the additives is one thing. The other thing is the nutrition. So typically the carbohydrates that are added to processed foods are highly refined carbohydrates. Highly refined carbohydrates are present together with fats in high proportions relative to protein. What this means is that it's the worst combination because of the protein leverage mechanism. Low protein diluted with simple carbohydrates and fats is going to cause us to overeat energy in a way that doesn't bring the benefits of healthy carbohydrates, as in the Okinawan diet. So the ratios of macronutrients are dialed in such that commercial interests are satisfied, and also private interests. It reduces the cost, increases the palatability, in many cases convenience because the shelf life is longer. So industry is meeting these kinds of needs, but it impacts negatively on health through the mechanisms that we now understand. And then the final thing is that, or two other things. One is it's not only that low protein, but fiber's been removed. And of course, what that means is that we overeat fats and carbohydrates, and the other brake on our appetite system has been removed. So that's going to end in problems, and indeed it does. And finally, there are what's known as empty calories. They don't come with the vitamins and the minerals that come with responding to strawberry flavor in natural strawberries. We're responding to it in an ice cream, which is a very different scene altogether. So it's really subverted the relationship between our biology and our food environments in a way that is more beneficial to industry than it is to human health.
Now, you bring up in your book, and I think I want to bring it up now, you compare this to big tobacco and the deniability of, how big tobacco kept denying that all this was happening. And there's a wonderful book called Merchants of Doubt about, which you probably know. Tell me, how does big food and big agriculture manipulate us like big tobacco does?
There have been many, this isn't opinion, there have been many formal studies on this, particularly using documents that have been released for public view, formal research projects. And there are many tactics that are used. It's not only big tobacco and food, it's oil, it's climate change. Whenever there are big stakes in terms of financial benefits, you get these things happening. And what it is it's a strategy overall that casts doubt on the scientific evidence that points to the problems associated with these products. Firstly, that's the one prong of it, is casting doubt. The other prong, and that's what the Merchants of Doubt is all about. It's a wonderful book, I agree. The other, of course, the insecticide situation, DDT, exactly the same thing happened. So it's casting doubt on the scientific evidence that points to problems with the products, and the other is exaggerating the benefits. It's causing confusion, not only among the general public, but really importantly among policymakers. It's a big step to go from science to policy, and what the strategy here is to prevent that from happening. And unfortunately, I can see it from a commercial point of view. It's a very important thing for an industry to do in its own interest. But unfortunately, it comes up against social good. It comes up against health, the environment. So they use these strategies, and they are multiple examples of how they actually go about doing this, including selectively funding research that is more likely to provide support for their products, rather than to point out the problems or to deny the problems, and the various mechanisms through which this takes place. They have a whole arsenal of strategies that they employ.
Well, we've covered heaps of topics today, as you Australians would want to put it. So let's talk about takeaways for the folks at home. How can people determine how much protein they should be eating? You got any guideposts for us?
There are various ways. It's easy to do. The one of the USDA has a very good nutrient calculator you could go to and put in your details, and it will tell you exactly that information. Another way would be a simple rule of thumb for this would be to take your body weight in pounds and multiply it by 0.36. And then what that will give you is the number of grams of protein that you should be eating on a daily basis. A very easy thing to do. USDA will be more accurate than that because it provides numbers that are specific to your age, and it's a more refined estimate. But that's a rule of thumb. In our book, we also provide another approach which involves using something called the Harris-Benedict equation for calculating your daily energy requirements, and then you multiply those energy requirements by the recommended protein requirement, for example, proportional 15% protein, for
15%,
example.
yep.
Yep, you multiply daily energy by 15%, and then that will give you the calories in protein you should be eating. If you divide that by 4, you get the grams of protein you should be eating on a daily basis. But one really important thing is that no animal in the history of life has used any of these methods to estimate its daily protein requirements, and they get it right. So our argument in the book is that you might be interesting to just get a guide to help you sort of focus on these things by calculating what you need, but ultimately it's going to come naturally. Just allow your appetites to do the wonderful work they've evolved to do, but in the right environment. Don't expect them to know how to cope with that instinctive regulation in an environment that's full of processed foods, because that's where the process goes wrong. If you surround yourself with foods that are the kinds of foods that our appetites know how to deal with, you'll get fantastically healthy outcomes in the way that so many other human populations have done before the arrival of processed foods has displaced their traditional food cultures.
So that sounds like intuitive eating, but what if I have an intuitive appetite for a quart of ice cream every night, which the food companies have given me that appetite for? How is there a step to start to overcome this?
Well, this is the thing. Why did you develop that appetite? So the problem is that this is what the ice cream culture. There's nothing wrong with having some ice cream, and it's just a question of overeating that type of stuff. But the thing is that what you want to do is when you're eating that ice cream, it's your natural appetites craving something, and the question is, what do you give them at that point? If you gave them something that satisfied your carbohydrate and or fat needs that wasn't an excess of ice cream, you wouldn't have that problem. You would satisfy it. The problem is that it's so easy and in the short term so pleasurable to engage those appetites with the wrong kinds of foods that's what ends in the problem. Occasionally, no problem doing that. We all like to have fun eating, but the problem is it's the frequency with which you do that.
So do you have any protein sources that you recommend more than others, or protein's a protein?
No, proteins aren't protein. I mean, there's a diversity of proteins, like there is with carbohydrates and fats, but especially on a vegan or to lesser extent vegetarian diet, you've got to ensure that you get the right balance of protein providing foods in your diet so that you get a complete protein. It's not that much of a problem with an omnivorous diet, because animal derived proteins provide the amino acids that could be deficient in a vegan or vegetarian diet. So that's the one thing. That's not a particularly large challenge. It might be in food insecure situations. In our modern environment, it's very easy to eat a healthy balance of proteins. The problem and the challenge is what comes along with those proteins and what doesn't come along with those proteins. So, for example, you can get very healthy protein in a fast food burger, but all of the other stuff you have to eat and the stuff that you don't eat, like vitamins and minerals, mean that overall at food level, that's not a good source of protein. It's not so much the protein, but it's what it's packaged with in the diet that you eat that I think is important.
Are there any superfoods or surprising foods that you recommend that people might not think of?
I prefer to think so many things. Humans are generalist species. There's such a wide range of things that can play a really important role in balancing a healthy diet that I don't like to single out individual foods among those. What my research has suggested is that we've really got to consider what are the wrong foods to be surrounding ourselves with. There's a vast variety of really healthy foods, and we can combine those in a diet to have very healthy, balanced outcomes. So junk food more than superfood is the way that I think about it. And then within the range of foods that are not junk foods, Eat a variety of those, and let your appetites help you select what variety and how much to eat at what time. In that way, you can have a super diet without a silver bullet concept of a superfood. But if I was pushed on one thing, is I was pushed to nominate one thing, I'd say that there's fantastic potential in pulses, in beans and lentils, in terms of being a very healthy source of protein that comes along with healthy carbohydrates, packaged with healthy carbohydrates, and fiber as well. Of course, in some, there are issues that have to be dealt with, as you would well know, Dr. Gundry. But,
as long as you pressure cook your beans or buy pressure cooked beans in a can or jar, I'm all for them. In fact, I have them multiple times a week. I agree with you. But you do have to, or traditional cultures have really good ways of long-term soaking, changing water, long-term cooking to deactivate the lectins in pulses. So yeah, as long as you know how to handle them, I'm a huge fan of them. So.
It's a really fascinating topic you've just raised about traditional cultures finding solutions to these things without the benefit of conventional science through observation. And again, it shows how well equipped our species, we've got all those biological machinery that we see in other species that we've spent 35 years studying. But on top of that, we've got this wonderful cultural ingenuity that enables us to adapt ourselves to such a wide variety of diets and eat healthy diets. Unfortunately, what we've done now is we've used that cultural ingenuity to do the exact opposite, to create a food environment that derails all of that. And we have an obesity epidemic and diabetes, cardiovascular disease.
Any thoughts on fasting? Obviously, humans are well built for fasting. We're the fat ape. And most animals go through periods of deprivation because of, ecological nightmares. Where does that fit in? Do we need to do it, or is it, useful, helpful?
I think it's useful. I think the problem with fasting is just as is the problem with an imbalanced diet, is it's not pleasant. It takes willpower, and we don't want to involve willpower in eating, which should be a pleasurable process. That's what it's all about. But nonetheless, a bit of willpower can be a very good thing. And just as is the case with low protein diets, provided the protein's balanced appropriately with healthy carbohydrates, what fasting does is it triggers the go slow pathways. And that's really because what it then is, it focuses our metabolism on repair and maintenance and mopping up all sorts of debris and stuff that's in the cells. So it can have very healthy, beneficial outcomes, and in the same way as what a low protein diet can do. The other thing about it is that fasting and also eating a variety of foods and a variety of diets and physical activity have another very important general physiological benefit, and that is it stretches. It's the equivalent of athletes stretching, but it stretches our metabolism. It exercises a kind of what's known as metabolic flexibility. It maintains the options open, the capacity of our metabolism to deal flexibly with a wide range of different fuel, nutritional type circumstances. And that's correlated with good health outcomes, whereas the lack of metabolic flexibility, which is often a consequence of going on strict diets, nutritionally imbalanced diets, the lack of metabolic flexibility is like an athlete not stretching, becomes specialized for a very narrow range of movements, and anything that takes you outside of those will end in injury. Biomechanical injury in the case of athletes, in the case of metabolism, will end in disease. And lack of reduction of metabolic flexibility is well known to be associated with diseases like cancers, diabetes, obesity essentially is associated with the lack of metabolic flexibility.
Yeah, that's actually the subject of my new book, The Energy Paradox. So yeah, you're right. The lack of metabolic flexibility is driving so much of our issues right now.
And we see it.
Right.
I have this wonderful project with collaborator Erin Vogel at Rutgers in the United States, where we're studying orangutans in the wild. They have the most immense metabolic flexibility, and it's a natural thing. It's because they live in an ecology where resources are available and they're not available. And they've evolved wonderful means, not as an emergency response, but part of their normal life cycle is to go through periods where they're relying on different combinations of fuels in different contexts in order to get through different ecological circumstances. So it's part of a primate evolutionary history. We're well capable of it. We just need to make sure that we exercise it and retain it and don't lose it through eating inappropriate diets.
So why don't we just all eat like a chimp or an orangutan?
Well, to some extent we do. Both the examples you've mentioned, just like us, have these nutrient-specific appetites for different nutrients. Both of those examples, when they're confronted with nutritional imbalance, what they do is they prioritize their protein intake on a daily basis, resulting in a variation in fat and carb intake. So those are close similarities. And also the orangutan is very interesting because in periods when it's surrounded by fatty and carb-rich fruits, it really pigs out on them. It becomes obese in the wild. But why it gets away with it is it's becoming obese because there are, and they know there are going to be times that follow where fruits are scarce. And then the orangutans burn the fat, so they use fat productively. What we do is we've created an environment which is like a perpetual fruit season for the orangutans, where we put on the fat, but we don't subsequently lose it. So there are lots of parallels between us and non-human primates. One important difference is you might, or your listeners might be thinking, well, how do orangutans become fat on fruit and why don't we? And the reason for that is that they have a gut that is adapted specifically for digesting a lot of the fiber in the fruit that they eat. So they have an enlarged colon, which is basically, it's the home of the microbiome. And when they eat a lot of fiber, that becomes fermented into an additional source of energy. So not only does it mean that fiber doesn't fill them up in the way that it fills us up. So you try becoming obese on apples and you'll see what I mean by that. It won't work because the fiber prevents you from eating that much. But if you juice the apples, get rid of the fiber, you'd be able to eat a lot of them. Well, orangutans don't need to juice them. They can eat a lot of them because it's beneficial for them to get the extra energy. Their fiber doesn't fill them up, and also it's an additional energy source for them. So that's a big difference between us and those primates.
Yeah, I tell all my patients we'll take a trip down to the San Diego Zoo and look in all the enclosures, and you will never find a juicer.
Although you will find obese animals in primates in captivity often, and the reason for that is that they are perpetually provided with high carb and fatty fruits, and then that can result in obesity, as it does in the wild, but with no opportunity to subsequently use that fat and reset the system.
Yeah, in fact, correct me if I'm wrong, but in my study of orangutans, female orangutans don't go into heat until the end of fruit season when they put on about 7 or 8 pounds of fat.
That's exactly right, and they and many primates are like that. Again, it's part of the nutrient sensing and how to coordinate the life cycle with the specific characteristics of their particular environment.
All right. Well, I've used up too much of your time. It was great having you on the show today, David. So where can our listeners find out about you and your co-authors' incredible work?
Well, the book's available in many, many bookstores, wherever it's available. It's widely available. You could obtain a copy there. We have a website, Eat Like the Animals website. We have our own research websites. Lots of information out there.
Well, keep up the good work. Again, folks, I I read the books that I invite on, and I really wanted these authors to be on the program, and you did not disappoint, David. So thank you very much. It's been a real pleasure.
Thank you very much for inviting us.
And I hope we'll chat again in the future.
I do hope so. Thank you.
All right.
Okay.
All right, thanks.
Bye-bye.
All right, it's time for the audience question. Ricky Resnick on YouTube asks, I've heard Dave Asprey say you should never eat roasted nuts, and I've heard other nutritionists say you should only avoid certain roasted nuts, such as walnuts and pecans, while macadamia nuts and pistachios are okay to eat roasted. What do you think about this? Well, here's the deal. Pistachios and macadamia nuts can go rancid very quickly. And I've had this experience more often than not. Particularly if you see a macadamia nut that is in half, I can guarantee you that it's already rancid. So I actually advise my patients, unless you know the pistachio farmer or the macadamia farmer and you go out and pick it up from them, which is pretty hard to do, please get your pistachios roasted as well as your macadamia nut roasted. I personally am a huge fan of raw walnuts, raw hazelnuts. Not a big fan of pecans, as many of you know, and I don't have the time to go into that today. But in almonds, please, 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 if you're going to eat almonds, take the peel off. Eat them roasted like a Marcona almond, but the peel has a major lectin in them. And I have a number of my autoimmune patients who clearly react to even almond flour. But that's a great question. You just got to be careful with raw nuts. One other comment. There are a few women who react to the tannins in walnuts, and that's where soaking nuts probably really comes in. I'm not too worried about the phytates in nuts, I'm really not, but soaking walnuts may be useful if you notice that you get kind of a burning sensation in your mouth when you eat walnuts. So, great question. Now it's time for the review of the week. This week's review comes from our supporter on iTunes, Let Go, who writes, Dr. Gundry's podcasts are the best. I watch him on YouTube and listen to him on Apple Podcasts. Excellent, honest information about what's going on in your body and how it all comes up from our gut. Well, thank you very much, Let Go, for your kind words. And I want to remind all my listeners to subscribe, rate, and review us on iTunes. Honestly, these reviews make a huge difference in how many people we can reach with our message about diet, nutrition, and health, which is why you can play a major role in helping other people across the globe transform their health and energy, all by rating us and reviewing us on iTunes. I can't wait to read your review soon because I am Dr. Gundry and I'm always looking out for you and your review. Before you go, I just wanted to remind you that you can find the show on iTunes, Google Play, Stitcher, or wherever you get your podcasts. Because I'm Dr. Gundry, and I'm always looking out for you.